When I joined Twasta, I just had a couple of things on my mind. But one of the problems they face is, how do I ensure this coating dries up really fast? I cannot wait for 24 hours, 48 hours for it to dry. How can architects directly understand? Once new technologies comes in, so now it opens up horizons of our engineers. Now I can afford to design something because it's not, we are humans by innately, we are imaginative people. So we can imagine stuff. But if this imaginations cannot be brought to realization, slowly this imagination dies down. So you start tunnel visioning into, okay, this is what I can do.
Hi, hello guys. Thank you for tuning in to watch this long format of us talking. So let's begin with some introduction. Myself, Yusuf Madar. I work as a machine design engineer here at Twasta Manufacturing Solutions. And I have with me here today Mr. Pragadishwar, who is the CTO missions of Twasta Manufacturing Solutions. So hi Praga, can you take us through how did you join Twasta and how you have been helping them so far?
Thank you for the introductions, Yusuf. So I started Twasta somewhere around 2016, 2017. At that time, I had a bunch of smart students who come to me and they were like starting something new. And it was a fairly exciting opportunity for me as well. So if you join any other place, you are going to be a part of a wheel. So now you get to develop something from scratch. So it was an exciting opportunity. So I took it up and I joined Twasta as a software engineer. So where I used to build the software which we use for 3D printing. So after a couple of years, I kind of got sold by their enthusiasm, and I got sold by the vision they had and the narrative which they are trying to build. So I started doing automation also. I started taking up automation also under my wing. And after a couple of years later, now I took their mechanical side aspect. Now I am sitting here as the CTO of Twasta.
But I understand it has been an exciting journey for you, but it's so brave. Like at that instant, like when you finish college, how did you choose okay, I will give this a shot? How did you bring up that confidence? Like what made you choose this career path?
I wouldn't say like it's a lot of confidence. I would say it's more of a mix of dumbness and confidence together, you can say. So, like you are fresh out of college, you have a lot of confidence under yourself. You don't especially know the real world, right? So you are fresh to the world. So you had a lot of confidence going in, and whatever I felt they were building is fairly
But
interesting.
I'm sure you would have had a lot of boring opportunities. Like when compared to Twesta, it would have been boring for you. But I think, that makes. I think the technology was the key thing, which drew. But did you expect you would have this sort of a growth, like when you joined Twesta at that point of time?
Definitely not. So to be brutally honest, when I joined Twasta, I just had a couple of things on my mind. So let me get a really good exposure to all these things. Let me see how a company gets built ground up. So let me just get this experience in. But definitely it has all its doubts. Like you keep doubting it throughout the way. But there comes a point where you start actually believing in the product you are building. So it starts with you are experimenting something. It's similar to one of your college projects, right? So you start building something. At some point, you get a feel like, okay, this is actually going to make a difference to the world. That's when all the passion and enthusiasm starts to come in, and that's when you also feel like, okay, this is something I'm going to stick and see through the end.
Okay. Yeah, that's really something because I think now if you look at people who are coming out of college, for them to even think about such an endeavor, it's a huge risk looking at because the idea of something that great turning out to be actually great is very rare. So I really is an inspirational story is what you have here. So let's at the end of today, I just want to understand a few things going back. I know at Twasta we have developed so many things, but I want to understand where it all began, how 3D printing began, how do we see 3D printing and how it has evolved to the form it is today. So let's start with like a very simple question. Can you tell me what is additive manufacturing and what is subtractive manufacturing, and what do you see as the difference between them?
Yeah. So fundamentally, subtractive manufacturing is a place where you have a really big block of any material and then you start slowly removing material. You subtract material slowly from it to achieve the final form you want. So some of the examples are like sculpting, every woodwork, doors, everything you see, it starts with a really big log of work and then they slowly remove whatever parts they don't want it and then it becomes the final end product.
Okay.
While it's just the opposite in additive manufacturing. So additive manufacturing is a manufacturing technique in which you start adding material slowly step by step to achieve the final end product. So one of the nature's example is how a bird builds its nest.
Okay.
So it starts with a really small piece of stick, a straw. So random stuff it finds lying on the ground. So,
Okay.
but it slowly builds it up to something as a final product. It requires like nature has figured out a way to do this a long time back. So it has took a while for us to reach here, but I'm glad we are here.
Yeah, I think like one is like obvious, like subtractive is like you can do it very simply. Like there is no, there is complexity to it, but looking at from a layman perspective, it is like something you can do much easier compared to additive manufacturing, is what I understand. But like from your experience, can you like break it down why subtractive manufacturing has been so dominant in the industry, and additive manufacturing is something relatively not yet there, and people are catching up like really late. Why is there such a gap like between them?
I think this has to do more with the natural way of things in which human evolved. So the initial tools we had access to, like you take a chisel, you take a hammer, and all these tools were more aligned for subtractive manufacturing. What can you do with the chisel? You can remove material. You cannot build stuff from ground up with a chisel. So this is one major limitation, and the second one is the vision to build it. So I have a model which I want to build. So it's easy for me. Say for example, I want to make a ball. So I have a really big block of wood. So I slowly start removing it step by step, and then I can imagine, okay, this doesn't look like a ball. Maybe a little bit more shaving here. So you slowly build to a ball. But if you have to do it in additive, you will have to reimagine the whole thing in step one. You need to know exactly where this piece of material needs to be laid for me to get this shape. This requires a lot of skill and
It's not
computational.
like really intuitive to look at. Additive manufacturing doesn't come like intuitively, but whereas subtractive manufacturing is more easier to imagine. Like you know the final shape of the object is supposed to be here, and all you have to do is like remove, like keep removing material till you get there. Yeah, I understand that.
It's a lot more forgiving as well, as you can say. So it's not like you make a mistake, you can slightly remove a little bit more and then you can correct it. But in additive, one mistake along the way like spoils your whole model. You cannot do anything more after that.
Got it. Yeah.
So that's the reason. That's one another reason which I can think of is the materials which are available. So how do you bind different materials together? So that's something which took a lot of time for us to figure it out. I need a model, I can just remove it as long as it gets the shape. But how do I take two wood pieces and then join together?
Yeah, got it.
So this is something which it took a lot of technological innovation for us to come to a place where we are able to join two woods seamlessly without losing any structural integrity.
Yeah, the engineering for like for us to understand how they bond together, different that too, we have a n number of material that you have to work with. It could be clay, it could be polymers, it could be metal. So you have to build the background engineering to figure out how they bind together. And without that knowledge, additive is not possible. But I think subtractive is also, it scaled up in so many directions because the technology you use for let's say machining a metal part or milling a metal part, whereas you want to do some sculpture out of wood, you want to use a CNC router. The technology behind them is more or less same. You just have to size them up accordingly to the material that you want to remove. So it is like it could easily diverge into so many different applications. But on the other hand, you have additive where you're working with clays and you're working with metal, and these are like completely different materials, and they completely behave in two different ways, how they bind and how they like behave when you're trying to do additive manufacturing. So I think that's a bit of a challenge, as inherently it is there.
Yeah,
So
yeah.
we can't
Correct. It's a beautifully put, right? So you have beautifully placed it. So it was natural in a way. So you have figured it for wood, you just extended it for stone, you extended it for metal. So it was a easy way for us to grow out of wood. Initially, we didn't have metal, so we started with wood. We just made something with wood, and then it was easy for us to the same technique, slightly better tools. You did it for stone, you did it for metal. But if you look at additive, as you exactly mentioned, everything needs to be now discovered. The way in which a wood and wood bonds with each other is completely different from how a metal and metal bonds with each other.
So yeah, I understand that the engineering of like additive manufacturing is far more sophisticated compared to subtractive manufacturing. Also, it's like not one material, right? You have to work with so many different material, and they are like the total opposites. I understand that it has really been but I think now the technology is catching up. Like now people are more specifically targeting one kind of material for one application, and they have figured out so many different ways in which it is possible. Not only possible, it is also sustainable, and they're like making really good products that are like having like industrial use cases, which is like at the end of the day, that is the most important thing. So
And I think that's one of the reason why this is an exciting time as well for 3D printing, right? So now we have figured out how these materials are going to behave. So now we have opened up this avenue of like you are able to now build a lot of things which are sophisticated, and at the same time it sits well with the research we are doing. So
yeah, but I'm just wondering, even though additive manufacturing seems to be kind of like the more sustainable, or like the one which has least like wastage produced in the overall like scheme of things, whereas subtractive manufacturing inherently comes with some sort of wastage that you are producing, which is not sustainable, and it has a lot of problems with it. Why did it took so much time? Like why didn't additive manufacturing also like be like co-developed earlier? Like I think it came a lot long ago, but why it has not been accessible for a long time is my real question.
right. So to look at additive manufacturing, so one big breakthrough that happened in additive manufacturing is somewhere in 1984 or ish. So there is this guy called Chuck Hall. So what he did is he was trying to do this furniture coating. So what they try to do is they try to coat it with a polymer for furniture so that they will come for a long life. But one of the problems they face is, how do I ensure this coating dries up really fast? I cannot wait for 24 hours, 48 hours for it to dry. I want to sell these things as soon as possible. So then they were experimenting with this idea of, can I use ultraviolet light to cure these components? Can I make this resin dry really fast using ultraviolet
Some
light?
sort of activation given to
Correct. So this activation was his key idea. So he saw this happening, and then they had this material which, when applied ultraviolet light, it started to solidify. Then he thought, why am I just using it for one layer? What if I can just build 10 layers on top of it? Can I make a model out of it? So this was his thought experiment. Then he just tried to build it. So outside his work hours, he started like to experiment with the same material which he used in his day job to do this coating. He tried to change the shape of the ultraviolet light and then see if I can build it in specific orientations. And this is what created this new stereolithography, is the one of the earlier forms of additive
So
manufacturing.
the
we
idea
started.
was to build a layer by layer, but it came from something else.
Correct.
Yeah.
It's like that's how most of the innovation starts, right? So you start with a completely different application. Even some of the tools which we use today, like cordless drilling machines. So the main application why cordless drilling machine came for the space agency. So they were like, how do I drill something or tap something or do some activity in space? I cannot have wires running around everywhere. So can I make a cordless drilling machine? But now this has become an industry standards for every construction guy, every
All the domestic use cases are now cordless.
like a common man who goes to buy a drilling machine now doesn't want a corded machine, so he just wants to go with a cordless machine because it's much more cleaner, right? So that's the similar fashion for 3D printing as well. So this guy created this machine and he filed a patent also in 1984. And this patent was the key problem which came along with it.
So even though it was like what roughly 80 years back, 80
Something around like 40, it's 1984, so it's something around 41 years back. So this patent was filed then, and people like NASA started using these missions at that point of time itself, but it didn't become affordable or accessible to the common public.
Okay.
So the major reason how it became accessible is all these patents started expiring in the era of like
So it
2006
become
to
public knowledge.
correct, correct. That's when a lot of people were able to, they knew how to do it because it's not a, it's just an idea. So he got the idea, he had it patented it. So it was easy to replicate. When people started having access to do this, they started building stuff which were far and well beyond what even these guys imagined that could be possible.
That's where you have that divergence of like people started figuring out, I can do it to different materials as well, and I can use the concept of different kind of binding for that particular material as well. So that's where, I mean, he started with resin, but now we have polymers, we have metal, we have clay, we have concrete, we have so many different. Yeah, I understand. But like, how did like, as you were there in the beginning, from the beginning of Twastas, like about, so how do you see, did Twasta stumble upon 3D printing? In particular concrete, like how do you guys thought this was the technology that it's worthwhile to like pursue?
To be honest, like concrete wasn't our first choice. So this boom started happening at like 2014, 2010. Around that time is when once all these patents expired, like there was a lot of buzz around 3D printing. So the growth you see in the last like 10, 14 years, like all the growth you see in 3D printing has happened in the last 10, 14 years. So before that, there was this sleeping period of 20, 25 years where...
Although the technology is a bit older, people really didn't bother. Like, I think it applies a lot of, like, it is like the same to many other technologies, but in particular 3D printing, with the potential it has, it should have been like much before than it is. But still, yeah, never late. Yeah, you were saying?
Yeah, so we were, so it was a buzzword. So I won't say it was the hot topic in 2010, 2011 when we were doing our college, but it was there and there was a lot of buzz in the academic environments. So it hasn't become a hobbyist solution.
No one from the industry is pursuing it, but like, yeah, colleges I can understand.
Yeah, colleges started to see if, because they saw a lot of potential in it. So they just wanted to see if they can get their students educated on it. So people were exploring it slightly. And it all started with a couple of young students who decided like, okay, this looks like a completely new technology and it looks like a really interesting one also. So can we start exploring it? So all of this started as a 3D printing club in IIT Madras.
Okay.
So these guys went ahead and created, okay, it hasn't become a mainstream academic subject yet, but I feel like this is a really interesting tech. So how can I take it to how can I explore it? How can I make my students accessible to it? So they created a club called 3D Printing Club, and then they started exploring this technology. And when these guys finished college, they found like this is such a good technology. Let's try to build a business out of it.
Okay.
And to be honest, that was one of our starting points. So we didn't start with construction.
So up until this point, it was all like polymers, or how was it? Like it was completely polymers.
Correct. So we started with polymer only. So because that was the only thing which was highly popular at that point of time. So we started with laser sintering, FDM as a solution. We even did powder bed systems, binder jetting, and we did metal printing as well. So construction concrete 3D printing is one of the many things which we were exploring at that
like
point.
Exploring everything altogether, but you didn't particularly focus on concrete there, like at that point of time.
I would call this initial phase of like 2016 to 2018 is the exploring phase of Twasta. So where we weren't sure, we were active believers of the additive manufacturing process, but we were trying to see where it fits into the world, because tech on its own doesn't have any value on its own. Like it has to solve a real life problem, and we were just exploring what field will it sit the best.
Yeah.
So when we were doing this exploration, we had a concrete printer also at that point of time, a small R&D scale.
Yeah,
small printer.
I think it's a rip-off from an FDM like kind of a setup, but it can print concrete as well.
Correct. So it's a basic gantry system, but we had devised the materials behind it. So we did a lot of material research to build a material which is 3D printable. And then we had a material extrusion setup. So we made some modifications to the gantry, and we had this machine, and we were doing some experimentation on small models, material testings and all these things. At that time, there was this conference in 2019. So construction 3D printing conference, where a lot of delegates from different industries, the industry experts, the academic experts, all these guys came in together. and we had an opportunity to just showcase our mission as a part of this expo. We just showcased a demonstration of how concrete 3D printing works. And this was when we got introduced to some of the bright minds of concrete construction industry. So till this point, we were like just academics who are trying to build something, and now we got real industry connects. So people who are actually facing the grunt of the problems in the construction industry. So when we started speaking to them, that's when we kind of understood there is actually a really good problem we can solve here. Because construction as an industry, it's been there much older. Yeah,
It's one of the oldest industries we have.
correct.
As long as humans existed, you have to do construction.
Correct. So even to think about, if you see machining, cars, automobiles, much before it we were building houses. So houses is something, construction is something which we had for so long, but it hadn't absorbed automation as much.
Yeah.
So in between, we started this automobile industry, machinings and all these things, but these grew to be 80 to 90% fully automated at this point of time. But construction is something that were just staying
Somehow
back.
it was always lacking. Like, I mean, like, there was a lot of challenges, but yeah, it was always lacking compared to the manufacturing in the automation industry.
Correct. And one of the things we realized is it's not due to the nature of the problem. They just didn't have a tech that could solve their issues.
Okay.
So everyone had a lot of problems they wanted to be solved in construction, and we found like 3D printing is one solution which can solve a lot of their issues. So that's the reason why we started taking concrete 3D printing seriously, and then we started getting in touch with a lot of construction industries, material experts and stuff to try to understand what problem is the exact thing which we want to solve.
Yeah, I was wondering because even at that time, the real buzz was around polymers, not concrete, and polymers, even metals to some extent. But concrete was never in the hot seat. But I guess you guys took that bold decision to pursue concrete despite keep having the other options as polymers, where people were desperately trying to develop polymers and then metals. But you guys took that bold decision. Maybe concrete is the bigger one, which can explode in like so many directions. I guess, yeah, talking to expert, it did that to you. But like, did you have any other sort of like technological like breakthrough in order to like pursue this confidently? Like, can you explain a little more on that?
So actually it's an interesting thought. We were also under the impression of polymer is the next big breakthrough. We are looking at like metal is the next big breakthrough. And one of the things which was actually blatantly in front of us, we just missed it completely.
Okay.
It was the fact that construction industry is by default an additive manufacturing process. So you look at how they have been doing this process for so long.
Okay.
It was step by step, someone just laid bricks step by step. They imagined how this building is going to look like as an end product, and they were able to figure out how each step was going to look like. So this is one of the big barrier for additive manufacturing itself. So if I want to build, let's say I want to build a small cup. So how do I imagine how this cup is going to look at every layer? Like, do I have any softwares to do this? It was a really big challenge for us to bring in this additive manufacturing in the polymer industry. That's why you see completely new softwares which do this job, completely new machines which do this job.
So yeah, I understand that like the construction technology and construction 3D printing, they kind of like follow the same technique in some sense. So that's why it's easier to build on that technology. So that's what you're trying to say, right?
Yeah, more likely I would put it in a manner where, let's say, you had welding in automation industry, right? So welding was there for a long time and people were doing manual welding. When robotics was introduced, they figured out a way in which robots can now weld. So it is much more safer, but it created new job opportunities as well. So it was a skill up for the guy who was doing the manual welding.
Yeah.
So I see construction 3D printing to be something similar. So people were already doing a process which was similar to additive manufacturing. Now you are equipped with a tech which can enable you to do it better. So that's the way I see
So
it.
you're not trying to exactly replace anything here. You're kind of augmenting what you already do, but do it in a more efficient and like in a time-sensitive manner. And also this creates somewhat of a better working like environment for the laborers also involved. It's exactly like robot welding. But otherwise, if you compare the same thing to, let's say, machining techniques, I think there we are trying to completely like replace the like known method of like manufacturing.
Exactly. I wouldn't exactly put it as replacing, but I would say it as it's two different technology trying its hand at like to create something. So I have a product. I earlier I could just make it only with subtractive manufacturing, let it be any component. Now once additive manufacturing started coming in, so they started looking at which components are more suited for additive manufacturing. But it has two different technology trying to cater one particular product industry. But in concrete, that's what I see it as a really distinctive difference between construction 3D printing, where concrete it's never whatever they were already doing was also similar. Like you are just laying brick, now you are laying concrete. So
Yeah, I understand it now. But this again brings me to a completely different point. Like when I was studying, when I was like doing my engineering, uh, 3D printing, yeah, I've heard about it. I'm like aware of the technology. And the most common like 3D printing method is like with polymers, which is the basic FDM printer. And yeah, I was exposed to it as well during college itself. But why was I not like aware of concrete? Like, why was there no awareness among like whether institutes or colleges or just commonly among students? There is no awareness with concrete 3D printing. Why do you think that gap is? I mean, even today it is still there. Like, why do you think that there is this gap?
I would say definitely there is a gap in this space, and one of the major reasons which I think is mostly to do with the target audience. So when FDM got introduced, so lot of people tried their hand at it. They didn't clearly define this is the use case for it. So they didn't say this is meant for prototyping or this is meant for a particular purpose. People started making dental implants to started making aerospace components to anything. So even a clip in your house also people started making it. So that versatility of audience is one thing that causes a lot of innovation, right? So it's always 10 people sitting together and trying to come up with a solution.
Everyone looks at it in a different perspective, and they want to build different things out.
Correct. It slightly pushes the technology also forward. So I would rather say the 3D printers which we had in 2015, 2016 and the 3D printers we have today are much more efficient. They are more silent, they are more efficient. The finish of the prints are like becoming on par with CNC components. So this push didn't come because one guy decided I want to make like something like this, because they found so many applications for it. The innovation that happened in one thing started affecting so many people. So there was a drive to do this innovation forward. And I feel like that is one major thing that's missing in construction 3D printing. So the target audience is a small set of people. So your architects, your MEP engineers, your structural engineers, only people who are associated with construction industry are the only people who wants this technology to progress forward. And one of the biggest problem they face is the barriers in between. So you take a look at like 3D printers. One of the early adapters of 3D printers were engineers. So they had exposure to all these tech. And this wasn't a really big leap for them to start adapting 3D
kind
printing.
of like they come from the background to understand and like adopt the technology.
Correct.
Whereas if you look at construction, the typical civil engineer or an architect is not remotely even like aware of that possibility of even 3D printing.
Correct. So the tech, I wouldn't say they are not tech savvy, but the tech they have expertise in is completely different from the tech which we are building in. Automation is slightly away. So, but if you see them, so they are planning tech. So because construction is an industry which involves so many departments. So it starts with an architect, it goes to a structural engineer, your plumber, your electrician. So and now as it more and more complexity grows in, so you have different designers for different aspects of it. There is someone who has experience only in kitchen, so they do interior design of kitchen perfectly. So when so many people needs to come together and build something, so that means a lot of planning is involved in this. This is something which construction industry has figured out. So they have solutions, they have processes in place which assist them to enables them to work with each other to get a final product out, because you cannot in the end.
They kind of have the framework to make multiple teams work together under like one like project, but they don't have the technology to make it automated. Like they kind of do it manually, individually, but they still have a framework that they are working under.
Correct. So and that's one of the major gap which Basta tries to fill also, because it's not just the tech alone is not enough. People have to leverage this tech to do it. So just because I have a tech which is going to build your houses fast, if people are not going to design it faster or alter it faster, like figure out ways to innovatively integrate your electricals and plumbing into your systems faster, then you are not fully using this tech.
So that awareness has to come from, just like FDM printers, it has to come from the early adopters like architects, civil engineers. Everyone has to be like in that orientation, and then only it will reach like the widespread like situation like we have with other types of 3D printing now.
Exactly.
Otherwise, the concrete will still concrete 3D printing, even though it has the potential, it will always remain a niche segment where only like one type of like experts are helping it develop further.
So the way in which I kind of like, this is the analogy which I think. So if a set of 5 people or set of a small team which we are, who's looking at this problem can solve it to this extent, what could a society do? What could such a broad variety of people coming in with their ideas can do? So that's what keeps me excited to do my next day work itself. And this is a gap which is definitely there in the industry, and this is a gap which we are trying to fix. How can architects directly understand the feasibility of this technology? So can they see what is, how can you teach these architects to slightly think outside the box? So we have been like what?
It's kind of you're giving them a new degree of freedom there, like to explore.
Correct.
A tool that they can exploit further, like, and build their own like versatility out of it. So that's what we are trying to. I understand the point. It has to come. Even though as the industry people are trying to adopt it, it always has to come from the people who are going to work on it, like from institutes, and then people who do the groundwork, like architects and civil engineers. Then only the technology will take a widespread like awareness among the community. Then we will start to see like how like now we have FDM printers which are commonly used everywhere. We might see like at some point like concrete also will have the same kind of reach, and then people will know what is concrete 3D printing.
Like the idea is you are now making better products. It's not just you have made the product and then you have just found a better way to make this product. Now you have figured out a way to make a superior product. Because when robotics and even CNC came into picture, they were able to make only certain kind of components they were able to do it. Once new technologies comes in, so now it opens up horizons of our engineers. Now I can afford to design something because it's not, we are humans by innately, we are imaginative people. So we can imagine stuff. But if this imaginations cannot be brought to realization, slowly this imagination dies down. So you start tunnel visioning into, okay, this is what I can do. And I feel like construction is right now in that era. So where people have been thinking about, okay, a building looks like this, a building's functionalities is this.
They're kind of in that acceptance zone, like they know, okay, a building, this is what you can do. Like people will try to spend more money on the interiors rather than playing around with the superstructure itself. But now I think with the help of concrete 3D printing, you're breaking that ideology, and you're saying, no, you can explore so many different options, even in the structure of the building, making the space more efficient, all that ideas start to flow in. That's where like the difference like, start to come in.
Like that's where the tech becomes a problem solver. So till that point, it becomes a tech which has a lot of potential. So when it is getting integrated with these industries, when a structural engineer sees this and then sees, okay, maybe I can just add this solution in your printing. Suddenly I don't need load. This becomes a load bearing wall. My wall thickness comes down. I can now do roofs with this technology. So this, because they haven't been trained to think outside this box. So now we have the responsibility, like at Vasta, we also take that responsibility. We try to reach out to people. We do webinars to educate people on these things. So how can you teach these guys to slightly think outside?
Like just to have that, spread that awareness.
Correct.
I think that is like beautifully answered. The next thing I want to talk about is, when I say 3D printing, I am also aware of this, that it is not just one technology that has to come together to like do this. You need more than one kind of people, one kind of expert team to work on this. Can you just explain like what are these expertise you need? Like let's focus on only concrete 3D printing, and like can you break it down for us? what is the expertise required and what are the different types of people involved.
Right. So concrete 3D printing, if you look at it, it's a tech which starts from you have to have a design first. So can this design be even 3D printable? So if you are going to just make boxes, then it still can do it faster than conventional, and all these things you can bring it into picture. But is it more efficient? Is it a superior product? So that is one aspect. So how can you train your designers to make better products?
So you need like architects who are like exploring the efficient methods which you unlock with 3D printing.
Correct. Along with the structural engineers, because architects are imaginative people. Like from whatever experience I have, I see architects as artists. So they imagine
They
stuff.
bring in the creative like skill set.
Correct. But someone needs to string these creativities to ground, and that's the structural engineer. Literally, that's what they do. They put stuff on ground which stays on ground. So the structural engineers and this architects together, they have to imagine, but it's not just design imaginations. You have to reimagine how your structural is going to look like. Because we have been long thought of a methodology. There are clear standards which establish a building of this
provisions that like limit us to work with one sort of a
correct
like, rule, a kind of rule book, you can say.
Correct.
But now that is like have to be like revised, and then you have to come up with an entirely new rule book whenever we are saying concrete. Yeah, that is one aspect. And what about the material?
Correct. So this is the first side of things. So where your architects plus your structural engineers try to make efficient building. I wouldn't even say the designs which the architects are making the job harder for structural engineers. Sometimes these designs itself assist in the structural load dissipation. Because we have seen it so often in our mission buildings and all our activities. Certain structures spread the load much better than other structures. So if an architect, whatever he makes, it might not be just aesthetically pleasing, it's more innovative.
Kind of a high functioning part. It serves more than like just the form. It also has function to build into it.
Correct. So this is one aspect of it, and second is our material aspect of it. So you have made a really brilliant design which is going to be more efficient result. But how are you going to realize it? This brings back to our first point where we spoke about the tech, the knowledge to ensure the material bonds with each other in the manner we want. So it has two aspects to it. So first, once the product is built, it needs to have the same strength or even better strength than whatever was done in conventional. And the second one is, how does this building going to happen? So during the process, what characteristics it needs to because it's not just the end result we are worried about.
I understand. The concrete cannot be the same concrete which you use, like that will not work.
Correct.
So for the sake of 3D printing, you have to create some sort of a new mix that will be extrudable, like pumpable, all that parameters which makes you 3D printing comes into play. And for that you need a specific skill set. And then this is like your regular materials engineer, or like they're also working on something unique?
Right. So this, I would say it's a widespread of technology. So material research has been happening for a long period now. So, and people know how to make these materials. But it's just the use case for it. There was never a use case for a material which had to be made in this particular manner. So now, since this use case has come in, now we have a lot of people now who has this capability to do it. So we at Tvasta also have like a couple of people, PhDs from IIT Madras, people from different industry backgrounds who come and work with us and try to build this material, which is going to be 3D printable. So what we mean by 3D printable in simplest term is, when I just lay it on ground, it retains its shape. But at the same time, it's not so hard, then it becomes incredibly hard to just pump it.
You have to be in a kind of a sweet spot to, it has to be printable, at the same time it cannot like set really fast. So that is a kind of a unique combination. I can correlate like to that. The most frequent customers we have, we sell machines to a lot of like institutes, mostly like central government colleges who are doing active research in cementitious mixes, and they are all trying to build 3D printable inks for different application. It could be architectural, it could be structural, and it could be even cost efficient. All that factors are starting to roll in. I think we will eventually get there. That is one aspect. Then what about the machine side of things?
Right. So this is where it becomes, because till that part, it is about educating people. So people were already doing it. So people had a lot of expertise in making different kind of materials. So now they were just trying to adapt to 3D printing. Now the next step is machines. We have made brilliant machines which perform really well on whatever the harsh conditions you show throughout it. But how do you make it user friendly? The guy who is going to use it needs to be like as simple as a diploma candidate. Like I just have basic understanding on how to operate a software. I should be able to control a machine.
Like
So that's
we
how.
can draw a parallel between a CNC operator who can like do a routine operation with an expertise of maybe service and maintenance of the machine. It has to be like at that level. So it has to be like very user friendly, but at the same time it should also like kind of serve all its purposes.
Correct.
Like completely run autonomous.
Like in the end, we don't want this guy to be able to handle a lot of coordinations. So we want our machine to worry about all the coordination. It should be as simple as I want this model to be printed in this location, and then your machine magically makes this happen.
Okay.
So this is our vision behind, because as I have told you before, like bridging this gap between, we don't want people to have a really big barrier to adapt to this technology. So this is something we had it in our vision, and that's one of the important reason we tried to do the whole solution in-house as well. So we have our mission, so and the electronics, the mechanical design, the software, the whole set we try to do it in-house, because we have done it so many times and we know what makes it easier. So it was an iterative process.
Yeah, since you brought it up, like yeah, I understand architectural, structural, and material and mechanical. Can you just talk about the software side of things? Like how does it really matter? Why can't we use a regular 3D printing software and like get away with it? Why you have to build the software as well?
So I would put it as two major differences. One is the complexity of the software. So what is possible with an FDM printer is much more, because it was meant for an hobbyist. So who likes to tweak, who wants a lot of features, he wants to play with so many things. But most of the things fail. But when it fails, it's plastic which is just running inside a machine. You just lost some amount of plastic was lost. But when you start looking at construction, you are building a house where mistakes cannot happen. So you need to ensure the QC is on top level. So you cannot mess with a lot of these parameters. At the same time, the skill level that's needed to operate as well. So if you have 100 parameters in front of you which needs to be tweaked and everything has an impact on the output, then it becomes a much harder solution for anyone to learn and adapt. So that's one of the major reasons why we decided let's make our own software. We will make it in a manner which is really easy for people to use. We will keep it really simple. Do all the running a machine is going to have all the parameters that anyway there are 100 parameters. There are 100 parameters you have to worry about. But the end user doesn't have to worry about all 100. He just has
Keep it
to
like simple and light so that like anyone can learn it really quickly.
correct, and it needs to be forgiving. So that is the second thing which we thought about when we made our mission or even our software as well. What if he makes a mistake? So how can he correct it? Because this generally happens in construction industry. So you build a wall and then you realize, okay, something hasn't gone by plan, and they have ways to rectify these errors. So how can I have a similar solution? So we started building these features into the solution. How do you guide the user to ensure the QC is proper? While it is building itself, the cameras in the machine like looks at it and ensures, okay, this is building as per dimension. So you give a confirmation to the user, so he is not scared that he is doing something wrong. At the same time, you are making his job a lot easier. So anyone with a period of like 2 to 3 weeks of training can pick this up and start building. So this is the reason why we brought the software into it. But that's where we thought like the problem ends as well. So we thought, okay, we have got the design done, we have got the material done, we have the machine ready, software
covering
ready.
all the bases.
Correct. But one of the problems which we faced once we started doing this exercise is the process. So because concrete as a material is a complicated material to handle. So it comes with a lot of its disadvantages. Plastic is a really simple material to handle. It
is a time dependent material as well you're working with. Once you prepare concrete, it has like a clock running always. So you have to kind of, you have to use it within that working window. Unlike other types of material, it like stays idle for long hours. But yeah, I understand that point.
So concrete as its material nature, it offers a lot of challenges. And also the way in which concrete interacts with the rest of the ecosystem. So how do you ensure there are how are you going to lift these models? How are you going to move these models once it's printed? How are they going to align with each other once they are taken to site? So all these things we had to put in a lot of
Apart
research
from
into
the
it.
machine material, you also have to take care of a lot of planning. I would call it strategy. Like, how do you, once you print it, what is the next? How do you lift it? Maybe how do you transport it? How do you assemble it inside? This is all new. Like, no one like even covers these things. It's all completely new. And I suppose like as we grew, like we started like coming up with new ideas, new solutions to like kind of put this all into a package, and then that's what we are offering.
Correct. So that's when people are able to, because one of the problems which we faced in earlier times, we have been doing this from 2018, so it's been around 7 years. So we have done 7 years of trials to understand like what problems we face. We have completed so many projects here, like even in different locations in India, different geographical conditions, different weather conditions. So once you have done the spectrum, now you kind of understand what are all the problems which people face. Unless it's easy for me to just show a machine which can just extrude some
Just
material.
building a machine is like much easier to do. Whereas if you want to build a machine, also give the material that it has to print while keeping everything around that also working, and the process, that is much more difficult task.
In the end, it needs to be a win, not just for us. Your client also should taste that victory. So he should feel the end result. I have got a superior product which was made efficiently in a fix, without any uncertainties in time and money. So I'm able to clearly deliver this on time. So this value we want our customers to feel it, because we strongly believe the community is the thing that's going to push this thing forward. So we on our own are just enabling the community to make this push. So that is one of our key objective behind most of the horizontal deployment which we do. So or else there is absolutely no reason for us to build this whole ecosystem, right?
Yeah, Praga, I have been working on this technology also for quite some time now, but it really bugs me. Like sometimes I wonder if concrete 3D printing, will it be able to solve like all the construction related problems at some point of time, if not now?
It's definitely, it will be wonderful if it can do it, but I certainly don't think so. Concrete 3D printing, I see it as a part of a solution which the construction industry is facing, and we are solving a part of it using concrete 3D printing. But there are definitely things outside the scope of it. So, and we certainly address some part of it, starting from how the architects or structural people can can interact with our machines or interact with the processes, and we establish solutions on the other side of the spectrum as well. So once it's printed, how can it be installed on the sites? How can it be transported to the sites? So we have already addressing these problems which the construction industry faces, and that's one of the major reasons why we don't certify ourselves as construction 3D printing company, but rather as construction automation company.
What you're trying to say is 3D printing is not a one-stop solution for all your construction problems, but it is a one potential like way in which you can address a few problems.
Correct.
Like, what do you think like is the scope? Like, what else you can like try to address?
Yeah. So definitely, other than concrete 3D printing, there are solutions like facade printing and even noise barrier printing. So we are looking at like different applications using which not exactly concrete 3D printing, but solutions adjacent to it, automation techniques adjacent to it.
3D printing is only the superstructure part, but there are so many other activities with respect to a construction of a typical house that you have to cater towards. Till date, we don't have a practical solution or automation solution for all of those activities, but that is something like I think people are working towards, like, and we are also trying to figure out ways in which we can address all these other aspects of building a house apart from just the superstructure.
Definitely. So to even give you a tidbit, so referencing is one such solution which we are trying to address in this manner. So which might not be entirely relevant to 3D printing alone, but it's a problem which the construction industry always face, and we are trying to figure out automation
I think in
solutions
order to set up the machine, you need that sort of like accuracy.
Not just in setting up the machine, but also to exactly establish where this particular wall is going to come. So till date, people do. There are mistakes in construction sites where they have built a wall slightly offsetted, like slightly misaligned, and all these things happen till date. And this is also one of the problems which we try to address, because we see it as a win-win. So it's a problem which will solve some of our 3D printing issues as well, but also a construction automation solution as well.
But like, can it happen also when you use 3D printing? Like, is it a common like thing using a construction site has this kind of typical inaccuracies they work with? So we are trying to address it in general, or we are focusing only on the 3D printing aspect of like. I'm talking about the survey systems. I'm talking about how you set up the machine, how you set up the print for the building.
Correct. So I won't say it's specific to the 3D printer alone, but it's more specific to the idea of exactly where a particular wall needs to come. So how can you visually or augmented way in which you can see exactly this is where this is supposed to happen? Is there any way for me to prove that this is where this is going to happen, so that these kind of mistakes doesn't happen in construction site? So that is tech we are trying to build, and there are like multiple other techs also which we are trying to bring it into the construction automation solution.
Yeah, I'm just hopeful. Yeah, I think we are on the right track. Like we are moving towards not just solving one sort of a problem, but we are also trying to come up with the entire full stack package that we can help deploy for any given customer. And then that's the real deal breaker, right? Like you can't build one aspect of the entire like solution, and then we cannot call it, or we cannot make real sense out of it. You have to from end to end, you have to integrate it, and it has to feel like you're not doing any more additional work than just because you're adopting 3D printing like compared to the conventional method. So I think when that happens, yeah, 3D printing could potentially like solve a lot of problems. But then 3D printing alone cannot like solve every aspect of the problem, like every aspect of construction, like related challenges we face today. Yeah, that's been it. Like I had like a lot of insights talking to you today. So I hope like we get to do this like often a lot, and we'll try to dive more deeper into like other topics more relevant to concrete 3D printing in the future. Like really thanks for sharing your expertise in 3D printing and automation in general. Thank you.
The pleasure was mine. So I also had a lot of fun like speaking about all these topics with you. Hopefully our audience also gets to learn, and they also broaden their horizons on this topic.
Okay.
Thanks a lot for your time.
Yeah.